there's two core options that we will typically recommend or see used in this industry, but each come with different considerations. And again, we'll go through some of these, but one option is the transient plane source or TPS method. So this is the flexible double-sided sensor, conforms to the various ISO as well as ASTM standards. So this is one that we'll talk about. But another one is the TLS or transient line source. So this is a non-planar style sensor. It's actually a needle probe, which is inserted into the sample. I was kind of showing that sample prep image earlier in those slides. So the needle probe is one that does have some additional considerations on the prep side, but we do see reference to the ASTM D5334 standard for some of these for some of the concrete testing. And I'm going to kind of talk about kind of the comparing and contrasting between these two. That being said, one thing I have heard in discussions with some clients of ours, groups that are interested in testing, even in some publications that I've read, is kind of a general kind of consensus here that would say, well, TLS is better because it captures a more representative volume of this heterogeneous sample. And I wanted to take a minute just to kind of address this, if this is kind of where you're coming from, or if this is, maybe what you've been told, and kind of talk through it a little bit, because to a point, this can be true, but it's not always the case. And that's because when we talk about your evaluated volume, we have to look at your probing depth. And I'm using TPS here as the example to really kind of compare against that statement about TLS. The assumption that the TLS is basically the winner because it evaluates more doesn't hold up when you consider the fact that TPS comes in a variety of sensor sizes. By design, TPS, and actually why we relate the sample size requirements to sensor size, is because there is a requirement in terms of the measurement validation process, which is done through a series of checks, again, kind of outlined in the ISO and ASTM standards. But you have to match your evaluated volume relative to the size of the sensor. So your probing depth scales based on sensor size. So you can imagine if you were comparing a very small TPS sensor, so a 6 mm, or even some of the smaller, down to 1 mm sensor sizes, and you were to place that on, a heterogeneous material, well, then yes, a needle probe, which is inserted down, is going to capture more volume and be more representative. But through the use of the larger size sensors, you can actually, in some cases, get a larger evaluated volume than the TLS. So, that comment on TLS is kind of the be-all, end-all, more representative output, I would push back a little bit against. We actually have some different application highlights on concrete. You can find those in our tech library. There's actually one on the use of our 60 mm, which is a very large format TPS sensor, specifically for the testing of some of these more heterogeneous materials. Definitely worth kind of checking out. But all that being said, you still might be coming from, well, I've used TLS in the past. I think it's a better method. So I wanted to kind of show you the data and kind of give you some examples of, actual measurements on some concrete. So this was a lightweight concrete that we just had in our sample inventory. You kind of see it's, nothing too fancy, just general kind of coarse aggregate mixed into the system. And here you can see the two different setups. The TLS setup, where we had to drill, apply the grease, you insert the probe down into the sample, versus the TPS setup, which takes the two sample halves and you just insert the sensor in between to take your measurement. So we did both. And actually, when you look at the data here, the results between the two are near identical, within a couple percent. The idea here is, again, by matching a size, a TPS sensor that evaluates a volume that is representative based on the scale of heterogeneity, it is essentially, I would say, a negligible difference here. Where the difference really came from was in the total prep time and testing time. I kind of roughly timed myself on how long it took to kind of prep and get one measurement done. TPS start to finish about 2 to 3 minutes, compared to TLS, which was significantly longer. So, when you're looking at options out there, and again, you may coming from a kind of a habitual use of or hearing of this method is maybe more commonly used, I would say there are many cases, a few ways to go about doing the measurements. I would say either one in this case, of course, are good options. It's just if throughput is a consideration for you, if you've got dozens of samples you're trying to get through, well, shaving 5 to 10 minutes off each measurement is going to save you a lot of time over the course of a week, right? So just kind of one example there on kind of TPS versus the TLS method, in how that all plays out. Now, some of you who may be familiar with this or maybe picked up on it astutely may have noticed, well, I only have one sample, and kind of the setup I just showed with the TPS, of course, it's double-sided. You need to have two sample halves. So if you're stuck with one sample, what do you do? Is TLS your only option? And just to kind of address that, well, when you look at TPS, yes, your standard configuration is double-sided, where you have your two samples on either side of the sensor. But there does exist a single-sided setup configuration for the TPS method. So when you're limited to one sample, there are additional basically configurations or options that you can operate the sensor with to accommodate a limited sample availability. Single-sided TPS is essentially, just like I said there earlier, it's a modification of the standard sensor with an insulative backing material. It's a really great option for when you are dealing with, again, sample limitations, as well as samples that don't test well with a contact agent. A couple of the methods on Trident, kind of as I've shown there with the TLS, use a thermal grease or a contact medium between the sample and the sensor. Sometimes that can result in kind of changes or absorption into the sample. It can, fundamentally alter the measurement at the surface. So, using something like this is actually quite beneficial. Now, there are some limitations on single-sided measurements, specifically for insulative low-K materials, textiles. This kind of arrangement is not one that we would recommend. You get into some issues in terms of measurement bias, accuracy starting to really kind of drop off. But, for something like a concrete, which is, middle range conductivity, I think generally you'll see it anywhere from maybe like 0.4-ish up to like some more conductive concretes, maybe 5 watts per meter Kelvin or so. This is a great option, again, especially if you're limited on your sample volume. So again, you only have one sample, it's no problem. I actually did a test again on some, actually this was a Quickcrete sample that we kind of just made up in the lab. And I actually tested it with a double-sided configuration as well as single-sided. And basically what you can see here is, again, a very negligible difference. In this case, there's almost, again, either way would be a viable option here. You can see the TPS. This is the single-sided test jig, so you can actually get one that comes kind of pre-assembled like this. So you just drop it down on the surface of interest for measurement. So again, when you're dealing with your sample considerations, prep time versus sample availability, there are different options to look at in terms of getting you good thermal conductivity data.